The next step in learning how to work with the z-distribution is to work points or problems where I ask you to find a point in a distribution given a certain probability, like the following problem. You see, I'm asking the probability z is greater than z naught is equal to 0.6628. So you can see I have a normal curve drawn down here. So we'll put 0 in the middle, and I'll call this the z-distribution. Okay, this is the distribution of all the z's, and that's referring to this first z that you see here in this little expression. The second z, the z naught, is the point that we're actually looking for, the value in the curve. And here's what we know. See if I can draw a nice straight line or straightish line. It's about to, oops, I shouldn't have said anything. That's about the best I'm going to do. We know a lot about this point, don't we? We know the total area under the curve is 1, so the area above 0 is 0.5, the area below 0 is 0.5. Now this is saying when you look bigger than z naught, so I know that there's 0.5 over here, and I'll put it as 0.5000. See if I can write it in here. I can. And that's the area on this side of the mean. And we know that's always going to be the case in a symmetric curve centered at 0. So the question is, where's z naught? And these problems typically boil down to you trying to determine where the value of z naught is. And I'm going to walk you through what I'll call the logical approach. If you're a logical thinker, this should make sense to you. What this expression is saying is when I look bigger than z naught, I should see 0.6628. Well, when I look bigger than 0, I only see 0.5. I'm supposed to see bigger than 0.5 when I look bigger than z naught. So if I tried to draw z naught out here, well, if I looked bigger than this point, you can see that there would just be this small little probability out here in the tail. There's no way that's going to be 0.6628. It's much too small. And so the logical part of me says I got to move and put z naught to the left of 0. And so I'm going to draw z naught over here. Okay, so when I look bigger than z naught, I see the 0.5 here, and then I see this additional amount. And this additional amount, which I'll just draw with kind of polka dots here. It's tough to draw dots with this little marker, but I'll do my best. Okay, we're going to draw like weird shapes. This probability, I kind of like that better. This probability, this kind of crazy probability here, if I want the total probability to be above z naught to be 0.6628, and I know there's 0.5 here, doesn't this have to be the difference between the 6628 I want to find and the 0.5 I know about? Doesn't this have to be, in this case, 0.1628? And so the picture I've drawn now, the total area above z naught is the 0.6628. And then once you have that, now it's just a matter of looking in the table and trying to find the 0.1628. Here it is. It's right here. It happens at a z value of 0.42. And so the z value that we're looking for, that's a crazy knot there, is the value 0.42. However, it's not a positive 0.42. It's a negative 0.42 because we fall below the mean. And so you got to figure all that out. That's the logical approach. You got to consider, and a lot of times I'll ask students, why is it to the left here? And sometimes students say it's to the left because of the 6628. And I'll say, no, not quite. That's a piece of it. Other students will say it's to the left because you got a greater than sign here. And I'll say, no, that's not really the case either. It's actually the combination of those two pieces. Because when I'm looking greater than z naught, I see 0.6628. And I could more generally say it because I see a number bigger than 0.5. It's going to be to the left. If this was a number, and if the 6628 number was, say, 0.1628, it would be over here on the right. And so that's the logical approach. And I know there's some people that are watching this right now thinking, oh, I see that. And there's a whole host of you that are saying, nope, don't say it. Can we do another one? And, of course, the answer to that is, yeah. Now, because of the camera I'm using, because of some issues with, I was in PowerPoint and I was working with something called Mix, and then because I'm working with Camtasia, the two don't like to talk to each other, so I'm doing this video maybe a different way than I've done before. I can't have a fancy transition, so what I'm going to do, what I think I'm going to do, let's see if I can make this work, is I'm just going to go to the next slide. Okay, so here's the next slide. kind of weird how I had to go about do that, but here we go. So I want you to find a point in the distribution z naught such that the probability z is less than z naught, so I switch that around, is 0.3372. And so again, I have a z distribution. Here's the value 0. One way of walking through it is just what we did. Try to do it using the logical approach. And here's what typically happens when I do this. If I'm up in front of a live class, I'll say, where's z naught? Try to think your way through it. Know what, we know what we know here. The total area under the curve is 1, so there's 0.5 on either side is 0. And here's what I find. If that last problem, if part F, if you look at the way I've lettered it, if part F made sense to you, you can probably figure out part G, because we went through the logical method. So what I want to do in this particular problem is I want to think about it a different way. When I look less than, which direction is less than? And usually that's a pretty easy question, right? When you think less than, you think below. So we're going to look over there. When I look below z naught, this is the amount I'm supposed to see. And again, if you're thinking the logical approach, you probably have it. If the logical approach didn't make sense, you don't. So I'm going to do it a different way. The point is this less than says we're going to be putting probability in this lower tail. And so what I'm going to do, I'm going to do something kind of weird here. I'm going to draw the curve, and I'm using my mouse to draw. Let's see what kind of curve I can draw. And it's not my best. It's not my worst. There's my normal curve. Just go with me here. And you're thinking, why did you draw it that way? I wanted the lower curve down, because what we're doing, what this less than sign right here indicates, is that we're going to put probability in the less than, or left hand, tail. And so what I'm going to do, let's see if I can draw this. This is another good little picture here. You might be wondering what the heck that is. That's a pitcher, like a pitcher of, one of my favorite things to drink is a pitcher of iced tea. I love sweet iced tea. It's one of my favorite drinks. So that's supposed to be like a pitcher, P-I-T-C-H-E-R, of iced tea, except that would be silly. I'm not going to do a pitcher of iced tea. I'm going to do, and here's the level of the, it's not tea, it's a probability. It's a pitcher of probability. How much probability? 0.3372. That's the probability I have in here. Okay, and what I want to think about doing is pouring the probability in the tail and let gravity take over. Because here's what I know. This less than says put it in the lower tail. This 0.3372 says how much you got. And why this tends to work is because we've all been in that automobile that's either run out of gas or almost run out of gas. And we all know what it means when it's halfway. Now, some of you may argue that the tank is half empty. Others may argue it's half full. That's a philosophical discussion we'll get into sometime later. But here's what we know. If you have 0.3372 and you start filling up, you're not going to be able to get to the halfway point. You're going to stop short. And that place you stop short, that's your value of z naught. Now notice, if I had 0.6672 like we did, or 6628 I guess is what we had in the last problem, I wouldn't be able to stop here. If I was pouring in a probability in a less than tail and I had 0.6628, I would have to go past the 0.5. But because it's 0.3372, I stop short. And let's see if I can pull down a different color here. You can probably see this. I'm going to do the blue. But here's what you got to figure out. Because our table always deals with inside probabilities, you got to figure out what this inside probability here is. In this case, we know there's 0.3372 down here. That's not the inside. That's what I would call a tail probability. So how would you find this probability? Isn't it the difference between the 0.5 that's below the mean and the 0.3372 that's below z naught? And so when I do some quick math here, and all of a sudden you're going to be like, wait a second, or at least I hope you say that, it's 0.1628. And now you should be thinking, wait a second, that's the value we used on the last page. And I'm going to say, you're right, it is. It's right here. This is the same problem. The z naught here is also a negative 0.42. You get the 0.42 from the z table. You get the negative because we're below the mean, because we're on the lower end of the tail, or the lower end of the curve is a better way of saying that. And so it's a weird way, pouring probability into the curve. It's a weird way to think about it, but as weird as it is, just from experience, I know a lot of you guys are going to benefit from it. And so that's why I want to take a look at it. All right, so I got to do my pause. I'm going to pause the recording for a second and get the next slide set up, and we'll go through one more example. All right, so we'll do one more of these. We'll take a look at it, and hopefully it'll make sense. That's not the one I wanted. Hold on a second. Let's do this again. All right, so let me make this bigger. There we go. That's still the same one. This is the one I want. There we go. Why is it not allowing me to do this? All right, we're just going to do it this way then. All right, so here we go. We have the probability z is less than or equal to z naught is 0.77 or 7881, excuse me. So you still see we have a less than here. And so the less than says, hey, we're working in the less than tail, so we're going to start filling it up. Now, whether you want to turn the distribution on its side so the lower tail is down, or you want to just shift the paper, however you want to think about it, we're going to be pouring probability from the upper tail into the lower. And so I'm going to start putting probability in this tail here, and I want to put 0.7881. Is there any way I can stop here? Is there any way I can stop below 0? Is there any way I can look at that and say, oh yeah, that's 0.7881? The answer is no, because we know this probability is 0.5. I have more probability than that. I got to keep pouring. I got to keep putting probability in. How much more do I have? Well, that's going to be, again, I'll get a different color here. Let's get the blue color. That's the probability in here. That's what you got to figure out. This whole z distribution, the table that we work with, is all based on inside probabilities. And so you got to figure out what the inside, when I talk about the inside, the probability between 0 and the z value you're looking up. That's what it gives you. That's what these probabilities in the lower part of the table are. And so if I have a total of 0.5 below the mean, and I have 7881 total, this has got to be the difference. So it's 0.2881. Now find that. Go find that in the table. 0.2881. Let's see. There it is. Happens at a z-score of 0.80. And so you always have to ask yourself this question. You get the z-score, you get the 0.8, you match it with the second decimal up here, the 0. Is it positive or negative? What side of the mean? It's above the mean, and so it's going to be a positive 0.80. And so those are the finding the point in the distribution type problems. We use these a lot. We'll use these for critical values when we do confidence intervals. We'll use these for rejection regions when we do test hypothesis. So this idea of working with probabilities in the tails is something you're going to have to work with, or probabilities in the under the curve, probably a better way of saying it. Now, I know where we're heading with this is to word problems. So I'm going to get away from the symbols and I'm going to get to words. And usually word problems make things more difficult, honestly, but in this case, in this particular application of word problems, it generally makes it pretty easy. Don't know if I want to use that word. I don't want to throw that word around too carelessly, but if I ask you to find the top 20%, you probably have a pretty good idea what side of the curve you're on, right? The top 20% is going to be in the right. If I say the lower 10%, you're going to be in the left. If I say the lower 70%, you're going to be in the right. So you're still having to think through it a little bit, but typically the words make it a little bit easier. All right, so let's go here and see what happens. Yeah, I knew it would take them away. And let's get to the last page here. Always goes back to the preceding page. That's weird. I don't know why it does that. Doesn't matter. Here's the last page here. Let's get the pen out again. So our next step is to work with other normal curves. Okay. In this video, we were talking about the standard normal. Very few things have a standard normal distribution. There's a lot of normal curves out there. They have a mean of mu, a standard deviation of sigma. Total area under the curve is 1. Okay. So you have 0.5 over here. I'll just write it that way. You have another 0.5 over here. Total area under the curve is 1. And I'm going to ask you probability questions. And I'm going to ask you to find a point of distribution questions. I'm going to say GPAs are normally distributed with a mean of 3 and a standard deviation of 0.4. Find the upper 10%. I'm going to ask you what percentage of the GPAs fall between 3.7 and 3.8. What fall between 2.0 and 3.0. I'm going to ask you probabilities. I'm going to ask you points in the distribution. And the whole key, we looked at one normal curve in this video. We looked at the standard normal. But the whole key, using our z-score transformation, okay, we've used them to identify outliers before, but using the z-score, we're going to be able to solve all normal curves using the standard normals. That's why I can't emphasize enough to you how important the z-distribution is. Before you get any additional information, whatever form you're learning in, live, video, smoke signals, whatever it happens to be, however you're receiving this, you got to learn the z-distribution, and it starts now. Okay, so I want you to get off this video, maybe go grab a bite to eat, and then grab your book, take a look at some standard normal problems, and see how you do, and then we'll go from there. So the next time we get together, I'll pick up and talk about other normal curves, and we'll see how to use this z-score thing. Until then, so long.